So it's Christmas soon,
And, oh, you've got one as well?
yeah, I've got mince pies.
It's only November though, Triv.
Oh.
I don't know why you bought me this.
Oh, it's the savings.
Savings?
Yeah, they were
Well,
really cheap, so it's worth buying them just for the savings.
I'm quite a man for savings.
Yeah. Mm.
So,
And it's relevant because it's pie.
very clever.
Mm.
So, we're on to further equations, which is using the quadratics that we did in the previous chapter, hopefully a shorter video, but it's to do with intersections and other stuff.
Yeah, and we're going to start with other stuff, and it's just really awkward equations to solve.
Yes, so it starts off something like this, perhaps, equals 5 lots of x plus 2, and it says solve. So firstly, let's establish what does the word solve mean. It means find the values of x.
Mm-hmm.
So it's when you found the values of x using the discriminant or by factorising or even by completing the square, you were solving, but before then it didn't say solve, now it says solve. First step, if you see these things, to expand it and get it all onto one side. So you're going to have, change this for an x, just to mix it up a little bit.
Oh, so you have 2x minus 2 equals x squared plus 2x.
Now, if you have an x squared, you want to try and keep that positive if you can. That's why I made it x, just to mention. Rather than taking all this over this side, take all this over this side. So you're going to have x squared, you're going to take the 2x over, it's going to completely cancel. You can take the minus 2 over, it's going to become plus 2, and it's going to equal 0. And then you can solve that.
Mm-hmm.
Now, you could use the quadratic formula. B would be 0 in this case, so the capital of that. And then you could solve it and find the values of x. Alternatively, you could just take it over. No, you couldn't, that would be a minus, don't do that. This has no real roots. And that means it's not going to cross the x-axis. There is no values of x in this particular example. Because if you take it over, x squared equals minus 2. So x would equal root minus 2. And if you square out a minus number,
Your maths teacher explodes.
as do we, and that'll be good.
That was
because
bad.
Just eating a lot of mince pie. Well, he has. I'm still on mine.
Yeah, sorry about that. It's called undefined, so you just can't...
I made this example up on the spot, I wasn't prepared for that.
Mm.
But we'll mention it anyway. This would mean you can't solve it. You would say there is no roots for this case.
Yeah, if you did the discriminant, you would find that it is less than 0.
So you would say something like it would be that somewhere, something like that. It wouldn't intersect.
Mm-hmm.
Now you did that in the previous video, except it wasn't in this format. Now we go on to intersections.
So I did this in line graphs and line equations, where we had lines crossing and then we made the y is equal to say, or we used the two methods, substitution and the other one.
Yes, whatever it's called.
Mm-hmm.
So if we have y equals, say, x plus 1 as a straight line.
Yep, and then it intersects a quadratic this time.
X squared plus 2x plus 3. Now you cannot do the other method we can't remember the name of, because you can't minus them from each other, it wouldn't work, it doesn't make sense. So you have to do substitution.
And as they both equal y, they must equal each other.
So then you can say x plus 1 equals this x squared plus 2x plus 3.
Then you can move stuff over as we did in the last one, where we have x squared plus x plus 2, and then you can either factorise it or...
I think a good step first would be to use the discriminant just to see. Now, the step up here, this quadratic, if you factorised it and did the discriminant, you'd be finding out if it crosses the x-axis.
But if you then did the discriminant for this one, you'd be finding the x-coordinates of its intersections. And this will tell you if it intersects once, twice, or doesn't touch at all.
Well, the same rules apply in the b squared minus 4ac formula. If it's greater than 0, it will touch twice. This line will go through it twice, so it perhaps looks something like that, or it goes once, twice, 2 intersections.
If it equals 0, it will touch it once.
Perhaps a tangent.
Yep. And if it's less than 0,
Just
it
won't
touch at all, be two completely separate
straight
lines.
line. And these are your rules.
Mhm.
So when you combine it with a line, you're not finding the x-axis, you're finding the intersection. So let's give it a go. Let's do b squared minus 4ac
Okay,
on
so
this
b
one.
squared is 1 minus 4 lots of a.
So it's minus 8 overall.
Yeah, and that is
Minus
7, which means they don't touch at all.
So it could look something like this. It just wouldn't touch. Ever.
No. If we change this number to a minus, just forget the rest of the question.
Just forget all of this and just say it was at that would be
Different.
plus 8.
So that would be 9, which means it will then cross at 2 points, and then you can find out what the 2 points are.
Yes, and you do that in the same method you would before with the factorising, if this one factorises nicely.
Which it does.
It does, minus
Yep.
1 and plus 2. If you expand that out, you're going to get this.
1 and then minus 2, yeah.
So your x values will be x equals 1 and x equals minus 2 with the 2 points where it intersects.
But you would want the y coordinate as well, so like in the old equations, you have to put the numbers back into the equation.
That's right. And this is all a bit of a step up.
It is.
So you always use the substitution method, you cannot use the other one. And it's always for finding the points of intersection.
The other one's called equating coefficients, I've just remembered.
Well
Yeah.
done, well done. But you don't
Yeah.
use equating coefficients.
No.
This chapter also deals with stuff like Benjamin buys a garden, and you're told, say, the parameters might be x plus 6, and he cuts a small pond here with values, I don't know, say x and x minus 3 or something. Work out the area of this pond.
Or the path or something.
Or something like that.
And eventually you just find a quadratic like we did before. We won't go through one of these. You can ask us one and we'll go through that one, but they're just
Now.
sort of awkward with words as opposed to awkward with maths, so you won't do that now.
Nope. And that covers everything in this chapter. Be sure to use your discriminant.
Yeah?
Be sure to look at our previous chapter, chapter 3, where we do the discriminant rule and all the other stuff. But remember, if you combine a quadratic with a line by substitution, then when you solve it, you're not finding intersection with the x-axis, but with the line.
Which is very important and very handy as well.
Can be, yeah. So use the discriminant to find out how many times it touches, if it touches at all.
Yeah?
Before going on, this is where the discriminant is more useful.
Absolutely.
Test yourself.
I think so.
Oh, I forgot my mince pie.
Question time.
Test yourself, page 63, question 4 from this book.
Absolutely.
If you watched our previous video, we're not going to add anything extra to this. We think this does everything in the chapter.
We do. So the question is, find the x and y values that satisfy the simultaneous equations of y equals 2 minus x squared
2 minus x squared.
Yep.
2 minus x squared.
and x plus 2y equals 1.
2y equals 1. Right.
Yep.
Is that it?
That is it. So remember we were finding essentially where these two lines, one being a quadratic, one being linear, intersect, and we're doing it by substitution.
You could substitute in your x or your y, but this says y equals, so I think I'm going to substitute y.
I think you should.
So you're going to have
X plus 2 lots of this,
2 minus x squared.
and that will equal 1.
So first step is going to be to expand it.
Yep, so it'll be 4 minus 2x squared equals 1. Then it's nice to have a positive coefficient of x squared. To move everything over, making 2x squared plus minus x
Minus x
minus 3
minus 3
equals 0. Then we need to solve it.
Yes. Now, the coefficient of x squared is 2, so I'm tempted to use the quadratic formula unless you can quickly trial and error through.
No, I'm not very fast. We have a friend who's also called James who is very fast. But we're not. So we're going to do it in the formula.
Minus b, now it's already a minus, so for the first time in these videos I believe this is going to be an opposite.
Yes, it's minus minus, so it's positive, so it's 1. Plus or minus that squared, which is still 1. Minus 4 lots of 2 times minus 3, so that'll
So
be
it's going to become a positive. Over 2a, which is 4.
4. So
This equals
it becomes 1 plus or minus
1 plus 4 times 8
times 3, which is 24, which is 25, which is the root of that is 5.
So x equals 1 plus 5 is 6
Over 4, which is 2
3.
thirds. Is that right?
6 over 4 is 3 over 2, isn't it?
Yeah,
Not
sorry,
2
my
thirds.
bad.
Yeah, 3 over 2. And
Minus-
the other one is going to be 1 minus 5.
Yep, so
which
it'll
is
be minus 1.
Yes. So we put both of these into one of any of these equations to get
It doesn't
to
really
1.
matter which one.
I'll put the answers up here. So x equals 3 over 2
And
minus 1. Now for y,
we can put it into what would be the easiest.
I'd imagine this one.
Yeah, probably. So 2 minus 3 over 2 squared, that's 9 over 4.
2 minus
2 and a quarter.
is minus a quarter.
So that's what the first one is. And
and
the
then
second one.
2 minus minus 1 squared is 1.
Yep, so then it becomes
But it's minus
minus
1
1.
anyway.
So it becomes 1. Now you could write it in coordinate form, but that is fine as long as you keep it in the corresponding values. If you swapped these round, they'd probably mark you wrong because they think it's the wrong corresponding.
That's right. And make your way 2003 as usual. We try to do a past paper. This
Yeah.
could come up. It could
This
be this
could come
card.
And often fair equations are sort of part of a big question at the end or in the middle, and I think that's pretty much it.
So let's crack on for a cuppa.
Alright. So,
Further equations,
Chapter
chapter
4.
4.
and it just takes things a bit further, really.
Yeah, so it deals with the quadratic things, but sometimes it likes to have things on either side of the equals and you've got to take them over. It likes to start the question by you having to expand the brackets.
Doing all good things, it likes using gardens and working out areas in odd places.
And lastly, it likes to intersect with straight lines, which
Yeah,
is why
quadratic
you use the
straight lines.
substitution method only, not the equating coefficients.
Yeah.
Hey.
And then when you do the discriminant from there, it'll tell you how many times it intersects with those lines, and if you work out that bit, it will tell you the coordinates of the points of intersection, which may be 2, maybe 1, maybe none at all if it doesn't work.
And those are all the questions they do. We did a proper question
We
for an
did.
exam, as we normally try and do. If you have any more questions, give us a message on Facebook or leave in the comments below.
Absolutely. So I think until next time.
See you at chapter 5, inequalities, I think.
Yep.
See you there.